Lesson 5.2, Solving Inequalities by Multiplication and Division. So we are going to solve the inequalities by multiplication and division and also be able to graph those. These are one-step inequalities again. And if you see a multiplication, you're going to divide. If you see a division, you're going to multiply on both sides of the inequality. But pretty much the most important thing that stands out is this. If you multiply or divide by a negative, you flip around the inequality. So the rule that we had yesterday, the variable has to be on the left. This is the second rule with inequalities. If you multiply or divide by a negative, you flip around the inequality. Now, it doesn't mean that there's a negative in the problem. It means the number that you're actually multiplying or dividing with is when you flip it around. So this first example right here is showing you the difference. If you would start with negative 3x is less than 6, and you had to divide both sides by negative 3. So see what I said? Divide by negative. Well, then you immediately flip that around. And you end up with x greater than negative 2. And if you had 3x less than negative 6, you're dividing by 3. Not negative 3, you're just dividing by 3. Then you don't flip it around. Okay, do you see the difference in those two? The number with the variable, if the one that you are moving to the opposite side, if it's negative, that's when you flip it around. Not just because there's a negative in the problem. That has nothing to do with it. Okay, so we're going to look at a couple of extreme cases because this is pretty basic step for algebra. The one that I do want to point out, just to refresh your memory, would be example A. Negative 2/3 x greater than or equal to 4. So basically what you would do is you multiply by the reciprocal of that fraction to make that fraction go away. So it's negative 2/3. We're going to go ahead and multiply by negative 3/2. So since it is a negative, we're going to go ahead and multiply by a negative. And you're going to flip it over. Since I just said multiply by a negative, I know that I'm going to turn that around. That's one thing. So a negative times a negative makes it positive. That's what we were going for over here on the left. Also, the reason why I do the reciprocal, look what happens. The 3's cancel out and become 1's. The 2's cancel out and become 1's. Everything there is just 1, 1. And I bring down then simply the x. It causes everything else to cancel away, which is what I wanted. For the right-hand side, I can think of it as putting the 4 over 1. And when I go to cancel, I can cancel the 2 and the 4, luckily, and become a 1 and a 2. And when I multiply straight across, I get negative 6 over 1, but I wouldn't write that. Okay? Now, there's no guarantee that when I multiply on the right that anything's going to cancel out on the right. It could end up with a fraction or something really messy. It's just the key is to get rid of the fraction on the left, so we're good. X is less than or equal to negative 6. So if you had to graph this, then you would put a negative 6 on there. And less than or equal to would be a closed circle, and you would shade left. Question, Ethan?
Wouldn't it be easier if you just multiply it by negative 3? The whole thing by negative 3, so you get 2x is...
But then you'd have to do another step. This way you're getting rid of both of them in one step. By multiplying by the reciprocal, you're getting rid of the whole fraction in one step. Torah?
Would there ever be a circumstance where the x
It could happen, and then you would have to definitely divide by a -1. You never want to leave it a negative. You definitely want to get rid of it. You don't want to ever know the negative value of the variable. You want to know the positive value. So divide by -1 in that case. Okay, anybody else? Those are good questions. All right, let's look at one more here. We are writing, you have to write the inequality. It says -5 times a number is at least 75. Let's go ahead and define a variable since we've been talking about that. Since it stands for a number, n sounds good, we're going to say let n equal a number, because that's what it stands for. Let n equal a number. And we need to take -5 times a number. So basically -5 times that n is at least. Okay, so we talked about this yesterday. What does at least stand for, Maitri? Greater than or equal to. At least is greater than or equal to. Okay? While we're writing, what's at most stand for? Jared? Less than or equal to. Okay, so those two could come up every now and then. So back to our problem. -5n is greater than or equal to 75. So then to solve, we would do what? Divide both sides by -5. And the minute that you think divide by negative, you got to turn that around. And over here, the 5's cancel. N is less than or equal to a positive divided by a negative would leave me with a negative, and 75 divided by 5 would be 15. Let me see if I can circle this so we get, this is our final answer right here. So I'm going to write it here, n less than or equal to -15. Okay, so you might have to write the inequality and then solve it. Watch out for at most, at least. Make sure you write the right inequality for that. All right, questions?